Well, hi there, and welcome to Lesson 4-7. We've got two goals for today's lesson. The first one, we want to be able to write a linear function rule for an arithmetic sequence. And secondly, we want to be able to use that function rule that we write to find the nth term in a sequence. But before we begin, you're probably wondering, what is this arithmetic sequence thing that she's talking about? Let me tell you. First of all, a sequence is just an ordered list of numbers that often forms a pattern. The sequence that you're looking at right now is very famous. It's called the Fibonacci sequence. Pause the video for a moment and see if you can figure out the pattern in the numbers. What would the next three numbers be? Each number in a pattern is called a term. The next three numbers are 34, 55, and 89. If you can identify a pattern in any sequence, you can often extend it and write a function rule to find any term in the sequence that you want. For instance, like the 100th term. Now, you're only going to be able to do that if it's an arithmetic sequence, because you only know how to write a linear function. So what is an arithmetic sequence? Well, in an arithmetic sequence, the difference between the terms is always a constant addition or a constant subtraction pattern. So let's take a look. I want to see if you can tell whether the sequence that I'm going to give you is arithmetic. And if it is, what is the constant difference? What's the pattern that you see? Let's look at this first one. 3, 6, 12, and 24. Is it arithmetic? Does it have a constant add or subtract pattern? Ah, no way. It looks like it's multiplying by 2, so that would be a no on that one. What about this sequence? 7, 9, 11, and 13. Is it arithmetic? Yes, it sure is, because between each term we see a difference of 2. We are adding 2 over and over again. It's constant. Let's try this one. 10, 4, -2, -8. Is it arithmetic? Is it a constant add or subtract pattern? Yes, it is. We can see that we are subtracting 6 every single time. Constant. And take a look at this one. 1, 2, 4, 7, 11. Is it a constant add or subtract pattern? No, it's not. It's an addition pattern, but it's +1, then +2, then +3, then +4. It's not constant. So in order for a sequence to be arithmetic, it needs to be a constant addition or a constant subtraction pattern in the numbers. And if it's arithmetic, you are going to be able to write a function rule for it. Let's specifically take a look at the sequence that I've circled here in yellow. What happens if you graph this sequence? Well, let's try graphing it. Let's create a table. Term 1 is 10, term 2 is 4, term 3 is -2, and term 4 is -8. Those are each of the terms in that sequence, so we're going to call them the x values. Of course, the y values would be the actual numbers in the sequence. Now, if I take that table that you see horizontally, and if I write it vertically, and then if I take each one of those points and graph it on the coordinate plane, check it out. I get a line. Anytime you have an arithmetic sequence, it's linear. And because it's linear, you know how to write a linear function rule. We can use the table to write the rule, just like we've practiced before. And boom, we'd have this rule right here. Oh, yes. So whenever we have an arithmetic sequence, we can write a function rule. And with that function rule, we can make a prediction for the nth term. Well, let's look at our goals now. See, now that we know what an arithmetic sequence is, let's try writing a function rule. So I want you to go to your notes. And in our notes, we're going to see example number 1 right here. Write a function for the arithmetic sequence and then use it to find the 10th term. Okay, this is the sequence I'm going to give you. So go ahead and write it in your notes. Now it's arithmetic. I'm only going to give you arithmetic sequences because those are the only ones that are going to make a linear function because it's a constant add or subtract pattern. Okay, so we're going to write a rule where we can figure out the 10th term in this sequence without actually writing out all of the numbers. Pretty awesome, huh? I want you to start off by making a table like you saw me do in that last example. This is term 1, this is term 2, this is term 3. So let's make a table and label that. Term 1 is 11, term 2 is 17, term 3 is 23, and so on. Now let's begin our function rule, always starting y equals, or you could do f of x equals. Now let's take a look at the pattern that we see. Okay, remember x is always on the top, y is on the bottom, alphabetical order. 11 to 17 to 23 to 29. What's that constant pattern? Yeah, it's plus 6. So I can see, just like if this were a table that was vertical, that constant y pattern is plus 6 and the constant x pattern is always going to be plus 1. So that is our multiplier. That's our pattern we see, 6 times x. Well, just to get from x to y, is it just multiplying by 6? No way. After I multiply the 1 by 6, I get 6. What do I still need to add to get 11? I need to add 5. So this becomes my function rule. Now, once I have this function rule, I want to find the 10th term. So imagine if I continued this, boop, 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 all the way to the 10th term. What would that be? Well, x is 10. So I'm going to plug 10 in for x into my function. 6 times 10 plus 5 would give me 65. That would be the 10th term in my sequence. Now I'm going to show you something. If I actually write out all the numbers in the sequence and continued it, 65 would be my 10th term. But we want to avoid doing this. That's why we're writing a function rule. Because imagine if we wanted to find the 100th term. Well, that wouldn't be very much fun writing out all those numbers, would it? Probably not. Okay, let's look at example number 2. Write a function rule for the arithmetic sequence, then use it to find the 30th term. Okay, write down the numbers in the sequence. Let's try this again. Before you know it, it'll be easy. Okay, so this is term 1, this is term 2. Let's put it in a table. Term 1, term 2, and so on. Okay, remember we've got x here and y here. Okay, function always starts y equals. Well, let's take a look at the pattern that we see in the y. What's happening every time? Yeah, we're minusing 5 every time. So we've got minus 5, and remember the x pattern is always going to be plus 1. And remember that y over x always told us what the multiplier was? So the multiplier is negative 5. Negative 5 times x. But do you just multiply the x by negative 5 to get across the table to y? If I multiply this by negative 5, I'll get negative 5. What do I still need to add to get 25? You're right, 30. Oh yes, there's our function rule. See, it's the same thing we've always been doing with tables. It's just you need to put the sequence into a table in order to do it. So 30th term. So if I continued this and I wanted the 30th term, what would that be? Well, that means that x is 30. So I'm going to plug 30 right in here for x. Negative 5 times 30, and then add 30. What's y? Negative 120. Well, imagine this. If this pattern continued and kept getting smaller and smaller and smaller, the 30th term is going to be really small. Negative 120. Let's try number 3. Go ahead and fill in the sequence in your notes. We're going to use the function rule that we write to find the 15th term. Okay, term 1, term 2, term 3. If it helps you, really encourage you to put this in a table. Okay, so here I'm putting it in a table. Remember, this is x, this is y. Okay, so let's start our function rule. Y equals. All right, what's our multiplier? Find that constant y over x pattern. So what's happening in the y? We're getting bigger, closer and closer to 0. We're adding 4, aren't we? And then, of course, the x is always going up by 1. So 4 over 1 is just 4. That's our multiplier. Okay, do I just take this x value and multiply it by 4 to get across? Do I just do that? No, of course not. It's a combination of multiply and something else. So if I take 1 and multiply it by 4, I would get 4. But then what do I need to do to make that 4 into a negative 15? I'm going to have to go backward on the number line, aren't I? I'm going to have to subtract 19. So this is my function rule. And that's going to work for any value. If I plug in 4 in here for x, multiply it by 4, I'd have to subtract 19 to get that output value. Okay, so next part, let's find the 15th term. So if I continued this out and I'm wondering what the 15th term is in the sequence, x would be 15. So I'm going to plug 15 right in here for x. So y equals 4 times 15, subtract 19. You just use your calculator for that, okay? And you're going to get 41. Well, imagine if this pattern continued. It's getting bigger, 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 bigger. If I kept writing it, I'm going to eventually get to 41 after the 15th term. Okay, let's try number 4. Go ahead and write the sequence of numbers. We're going to use our function to write the 20th term. We don't want to have to list all these numbers out to write the 20th term. I mean, imagine finding the 100th term. No way. Okay, so I'm going to put them in a table. Term 1 is 5, term 2, term 3, and so on. Remember, we got x and y. Okay, I know it's a little bit of work, but it's really going to help you out. Okay, function rule, everybody. What's our y over x pattern? 5 to 12. What's happening? Looks like we're adding 7 every time. Okay, that's our pattern. 7, this is going up by 1 every time. So 7 is our multiplier. So do I just multiply by 7 to get across the table? Do I just take this and multiply it by 7? Nope. After I multiply this by 7, if I took 2 and multiplied it by 7, I would get 14. What do I still need to do to get across the table? Minus 2. Same thing here. If I multiply this by 7, I would get 7, and I still need to subtract 2. There's my function rule. Okay, now I want to find the 20th term. So imagine if I continue this out to 20, what term would be there? So I'm going dot, dot, dot. All right, so let's plug in x is 20, 20th term. 7 times 20, take away 2. Use your calculator to help you. That's going to be 138, and that would be the 20th term. And imagine these are getting bigger, 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 bigger. If I kept going, I would end up with 138 for my 20th term. Pretty easy, right? Again, it's a lot like what we've been doing. It's just that you don't start with a table. You start with a sequence, and you have to create a table. Okay, on to the last one, number 5. Justine's grandfather puts $100 in a savings account for her on her first 3 birthdays. Wow, I wish that, or no, sorry, $100 in a savings account for her on her first birthday. And then he puts 125, 150, and 175 into the account on her next 3 birthdays. Wow, it would be nice to have Justine's grandfather, right? Okay, so let's write down the pattern of what's happening. $100 into the account on her first birthday. Then he puts 125, 150, 175 for the next 3 birthdays. Do you see the pattern he's making here? I bet you he's a mathematician. Who knows? Okay, so let's write a function rule for what Justine's grandfather's doing here. Okay. Well, we have a sequence of numbers. The only way we're going to get a function rule easily is if we create a table for this. So, first birthday, $100. Second birthday, third birthday, fourth birthday, right? Remember, this is X and this is Y. Term 1 is the first birthday. Term 2 is the second birthday, okay? So, function rule, Y equals, let's look at the pattern. What's happening? We're going up by 25, so that's our multiplier, right? Repeated addition is really multiplication, isn't it? So right here, multiplying by 25, but I can't just take the 1 and multiply it by 25. I can't just take the 2 and multiply it by 25. What do I still need to add? Yep, once I multiply this by 25, I still need to add 75, right? So this becomes my function rule. If this pattern continues, How much will her grandfather put in her account on her 12th birthday? Ooh, that's going to be a lot of money. So here, if this continues, this is her 12th birthday. Well, how much money is she going to get in her account if he continues this? So x is 12. So I'm going to plug in y equals 25 times 12 plus 75. And then, of course, I just use my calculator to figure out how much money is going to go into her account. And you can do that one on your own with your calculator. All right, I am hoping that now you feel like you've got this goal, that you feel like you can write a linear function rule for an arithmetic sequence, and you can use the function rule that you wrote to find any number term in the sequence. Thank you so much for joining me for lesson 4-7. You guys have a great day.